Good morning to everyone present here. Today's topic is Norton's theorem. First, let's go through the definition of it. A linear network consisting of number of voltage sources and resistance can be replaced by an equivalent network having a single current source and a single resistance. So you can see the diagram where we have three resistance, one cell, current cell, and one load resistance across the terminal A and B. We have to convert into a Norton's equivalent circuit where it consists of one equivalent resistance, single resistance Rn, and one current source In, and RL is the load resistance across AB. IL is the current flown through the RL. So using current division rule, IL is equal to IN into RN divided by sum of the resistance. The current division rule states that the current into the opposite resistance divided by summation of all the resistance. So first step, find the load on the source. Short the load terminals A and B. We have to short RL across the terminals A and B. When we short RL, this is the diagram we get it. So R1 dash is equal to R1 plus R2 parallel to R3. You can see in the diagram where R2 and R3 are parallel with each other in series with R1. When we equivalent or solve this equation, we get R1 dash is equal to R1 into R2 plus R1 into R3 plus R2 into R3 divided by R2 plus R3. To find the current I dash is nothing but V by R. V is nothing but E, where I dash is equal to, we have to substitute R dash value in the above equation. R2 plus R3 will be the reciprocal. We have to take the reciprocal in the numerator, where I dash is equal to E into R2 plus R3 divided by R1 R2 plus R1 R3 plus R2 R3. To find the Norton's current IN. Norton's current IN, it is we can write it as ISC also, short current circuit, where IN is equal to I dash into R2 divided by R2 plus R3. This is done using current division rule. IN is equal to, we have to substitute R2 value, we have to substitute I1 value in this equation. If we substitute I1 value, you will get IN is equal to E R2 divided by R1 R2 plus R1 R3 plus R2 R3. Find the resistance Rn, open the load terminals A and B, short the cell. We have to open the load terminals across A and B and short the voltage source or the E cell. So Rn is equal to R3 plus R1 parallel to R2. R1 is parallel to R2 and it's series with R3. So this is the final equivalent circuit which we get it after resolving all the steps. So let's go through the problem. So we have three resistance of 1, 3 and 2 ohm, 9 volt battery, and 10 is the RL. So IN, we have to convert into this equivalent circuit form, where we have to gain one load resistance, equivalent resistance, and equivalent current source. So to find the Norton's current, we have to apply KVL. We have to short the RL, we have to short RL across A and B. We have to apply KVL. If we apply KVL, we can see in I1 where it is 9 volt will be a minus 9 due to the current entering is in negative, plus 1 I1 plus 3 I1 minus I2, because I1 3 ohm is both in I1 and I2, and since we are using loop 1, we have to consider I1 as the first preference. So the equation will become 4I1 minus 3I2 is equal to 9. Then apply KVL to loop 2. When we apply KVL to loop 2, 3 will be same in I1 and I2. So we are considering loop 2. So we have to give preference to I2 first. So 3 bracket I2 minus I1 plus 2I2 is equal to 0. When we resolve this, we'll get 5I2 minus 3I1 is equal to 0. This will be the equation number 2. So we can see in the diagram that I2 is equal to IN, due to which we can, if we find I2 value, you can tell it that Norton's current is equal to I2. To find Norton's resistance, we have to short the voltage and open the terminal across A and B. So when we short, we can see this diagram. So RTH is equal to R1 parallel to R2 plus R3. So this is a formula, that is 2 plus 1 into 3 divided by 1 plus 3. You will get 2.75 ohm. So when we draw the Norton's equivalence circuit, IN is equal to 2.454 and RN is equal to 2.75 and RL is 10 ohm across the terminals A and B. So this is the Norton's formula, where IL is equal to IN into RN divided by RN plus RL. So 2.54 into 2.75 divided by 2.75 plus 10. You will get 0.5279 ampere. So this is the today's topic, Norton's equivalent. Thank you.